Let's be honest, AI is everywhere, but it feels like it's buried under this mountain of hype and jargon and, well, a little bit of fear, right? So, in this explainer, we're going to cut right through all of that noise. We're breaking down what AI really is, from the sci fi movies stuck in our heads to the actual reality that's sitting in our hands. Okay, let's get into it. And you kind of have to start here, with the big, scary stuff. I mean, when a mind like Stephen Hawking puts out a warning this serious, it's no wonder people feel a little uneasy. This quote, it just perfectly captures that high-stakes vibe that seems to follow AI everywhere.
But here's where things get weird. The myth that we all know is about conscious robots, evil plans, world domination, all that jazz. The reality is the algorithm that probably suggested this explainer to you. It's the spam filter that keeps your inbox clean. It's Google Maps getting you home without hitting traffic. The truth is, you and we're using AI literally every single day.
So that leads to the big question, doesn't it? If the AI we use isn't some supervillain in waiting, then what is it? How do we get from a simple piece of code that filters junk mail to these incredibly complex systems we hear about? How does a machine go from just following a list of instructions to something that feels like it's thinking? Well, the answer, the really fundamental shift, isn't about what computers do, it's all about how they learn to do it. See, we've gone from a world where we tell machines exactly what to do, step by step by step, to a world where we kind of let them figure it out on their own. And this right here is the absolute key. In traditional programming, a person, a human, writes the logic. They write, if an email contains these exact words, then you mark it as spam. Every rule has to be written out by hand. But with machine learning, we completely flip the script. We show the computer thousands of emails, and we show it which ones were spam. The computer then looks at all that data and creates its own logic. It's learning the pattern itself instead of just following our rule. Okay, to make this crystal clear, let's use an example that we can all wrap our heads around. Let's pretend we're a bank, and we want to build a system that can automatically say yes or no to a loan application. So here's how we do it. First, we just feed it tons and tons of historical data, all our old applications, and crucially, whether they were approved or not. Then the AI just sifts through all of it, looking for patterns. It might start to notice, hey, people with high credit scores and stable jobs usually get approved. And based on all those little patterns, it builds its own internal logic. We call that a model. And boom, now that trained model is ready. It can look at a brand new application and make a pretty smart prediction. And that entire process we just walked through, it has a name, machine learning. And really, this is the engine that's driving almost everything we call AI today. It's not about creating some conscious mind. It's about creating incredibly powerful pattern recognition machines. Now, you've probably heard a million buzzwords thrown around. Machine learning, deep learning, Gen AI. It gets super confusing, I know. So let's just build a really simple family tree to see how all these pieces actually fit together. Okay, think of artificial intelligence as the big umbrella. It's the whole field, the entire dream of making machines smart. Now, machine learning, like we just saw, is the most popular way we're trying to do that right now. It's a subset of AI. And then, inside of that, you have deep learning. This is a really powerful type of machine learning that uses something called neural networks, which are kind of loosely inspired by our own brains. This is the heavy-duty tech behind stuff like ChatGPT or the Face ID on your phone. So we know that machines learn from data. But just like us, they kind of have different learning styles. So let's quickly break down the three main ways that a machine learning model gets trained. First step is supervised learning, and honestly, the best way to think about this is like studying for a test when you already have the answer key. You give the AI a problem and you give it the correct answer. That loan example we used, that was perfect supervised learning. We had the application, that was the input, and we had the outcome, approved or rejected. That was the output. The AI's whole job is just to figure out the connection between the two. Next, we have unsupervised learning. And with this one, there is no answer key. You just give the AI a giant, messy pile of data and basically say, go find something interesting. It's like a detective sifting through a mountain of evidence looking for hidden clues and connections. This is amazing for things like grouping similar customers together for marketing or sorting thousands of news articles into topics without a person ever telling it what the topics are. And finally, there's reinforcement learning, which is all about trial and error. You have an AI, called an agent, that takes an action out in the world. If it does something good, it gets a reward, a little digital treat. If it's a bad move, it gets a penalty.
And over millions and millions of tries, it learns the strategy that gets it the most rewards. This is exactly how we teach an AI to become a grandmaster at chess or Go, or even how to control a complex robotic arm. So that's how these things learn. But with all this insane progress happening so fast, it is so important to understand the line between the AI we have today and the AI we see in the movies, and to be clear-eyed about the very real challenges we're facing. And this brings us to what might be the most critical distinction of all. Everything we have today, everything, is what's called weak or narrow AI. It might be literally superhuman at one single thing, like playing chess or recognizing faces, but it can't do anything else. It's a one-trick pony. The sci-fi dream of strong AI or general AI, a machine with the same kind of flexible, adaptable intelligence as a human, that remains completely theoretical. It just does not exist. But even with the narrow AI we have, we're facing huge challenges. First, there's the black box problem. The AI's internal logic can get so complicated that even the people who made it don't really know why it made a specific decision. Famously, an AI learned to identify wolves, but it turned out it was just identifying snow in the background, because most of the training pictures of wolves had snow. And second, maybe even more importantly, is bias. AI learns from our data. So if our historical data is full of human bias, say a company that mostly hired men in the past, the AI will learn that bias as a fundamental rule, and then it will amplify it. So, after all of this, here's the real takeaway. AI today is a tool. It's an incredibly powerful pattern matching tool for sure, but it's still just a tool. It doesn't have a consciousness, it has no intentions, it has no idea what right or wrong even means. So the fear of it becoming evil kind of misses the whole point. The much bigger, much more urgent question is a human one. How will we choose to use this technology? Because that is the question that's going to define our future.